I don't think there's a such thing as an official Gopher.
It's recording.
Can you like angle it a little bit so I can stand up?
Yeah. All right, I'll do it like.
Yeah.
Go this way. First few minutes, the only thing you'll hear is pizza sound.
I'm expecting some kind of presentation from Speechmatics first. Is that going to happen?
Yeah, please. Absolutely.
Yeah.
Woo! The man with the pizza.
So firstly, apologies about the pizza mishap. Some housewarming things. Toilets over in the corner. If there's a fire, which there probably won't be, you never know. Out the way you came. That's pretty much it. And welcome, Johan.
Thank you. All right, yeah. Getting started with the cues. Okay, cool. Hi everyone, and thanks for inviting me to talk here at the meetup. I'm really excited to introduce you guys to my open source project. My name is Johan. I'm a Swedish guy living in England. I've been here for about 6 years now. England's cool. So I work at a data collaboration startup called InfoSum. We allow companies to share data between each other in a GDPR compliant way. And the backend is all written in Go using gRPC and stuff. So I like to spend a lot of my time, my free time, working on gRPC stuff as well. But a lot of my work time is also spent with gRPC, so it's all consuming. So I have a number of open source projects, and I've contributed to the Go programming language. And I run a blog. The website will be there at the end. It's jbrandhorst.com if you want to check it out. If you haven't already, check it out, of course. And today I want to introduce my open source project to you guys. So let's take a quick overview of what we're going to be covering today. Oh, come on. Oh, there we go. Okay. Never know. Anyway, so we're going to learn about Protobuf, gRPC, gRPC-Web, and GopherJS. I'm going to introduce gRPC-Web for Go, which is what my library is called. We're going to create a simple app with gRPC-Web for Go. And because we have a little bit longer time, Michelle said you can type as long as you like, foolishly. I thought I'd give a little bit of a longer demo than I did. I've delivered this speech already at FOSDEM in February, if anyone was there. You've seen a lot of this, but there will be some new stuff as well, or if you've seen it online. And we're going to explore some of the challenges I encountered while implementing library and talk a little bit about the future as well. So let's start with Protobuf. Anyone know what Protobuf is? Yes. Yeah? Good, okay, yeah, okay, cool. Anyone using Protobuf for work? Yes, okay, Protobuf is great. Protobuf is an interface definition language, description language developed by Google, basically used for all of their internal communications and for storing long-term data and things like that as well. Mostly used for service-to-service communication. It has it's a binary serialization format with automatic backwards compatibility, and leverages code generation to support a lot of different languages. Yeah, and it's language agnostic, so you can write code, you can marshal something in one language and unmarshal it in another language. And so it's basically meant to replace JSON for your communications. It's much faster to marshal to and from the wire, and it's much more efficient in storage, of course. It has wide official language support, including Go, C++, Java, Python, and many other third-party implementations as well. And as far as I can tell, this is the best logo of the Google Protobuf project that exists, and it's like 300 by 100 pixels, something awful like that. So, what does the Protobuf code look like? This is an example of a Protobuf file, or a proto file, so to speak. We've got a syntax declaration at the top. Proto 3 is the one you should be using nowadays. Proto 2 exists as well. Proto 1, I don't even know what happened with that, but that doesn't exist. We have a Go package here, Go package class, which is something you should be using if you're using Go as well. It makes importing your generated packages much easier. We've got a package declaration, which is used for namespacing, and a simple message with some different types there. You see a string type, an unsigned integer type, and then there's this funny numbers on there as well. They basically tell the marshaller in which order things should be written to the wire. You don't really need to worry about them, except you must make sure that within the message, each scalar or message itself has a unique number. So this could be 5,000, that could be 6,000, that could be 2. The order doesn't matter at all. They just have to be unique. So what does the generated code look like? This is a snippet of generated code based on the previous profile. We've got a simple struct, of course, with the automatically camel-cased names. You'll have noticed that. Oh, sorry, wrong direction. It translates things like the lowercase. In protobuf, you use snake case for your names, and if I had any underscores in here, they would have been camel cased. But you can see, obviously, when we're working with Go structs, they have to be capitalized in order to be accessible. And it generates some getters like this as well. So you can operate on nil objects. If the struct was nil, you can still use it, for example, because it will just return the 0 value of the type, which is quite handy. Sometimes you don't get any unexpected crashes. Well, sometimes you want it to crash, so you may not necessarily use this. You can see how it's got some JSON tags in here, and also protobuf tags, which you can completely ignore. But yeah, the JSON tags obviously tell it that you can use the protobuf structs to marshal to JSON natively. Although the Go protobuf language has its own, the implementation has its own protobuf marshaller as well that you should be using if you are marshalling to and from JSON, because it handles certain complicated structs better than the standard library JSON marshaller. So this is the output of the normal Golang protobuf marshaller, but there exists a third-party implementation as well called GoproTo, which generates marshalling code as well, because the normal Golang protobuf library uses reflection to marshal to and from the wire, which is inefficient and puts a pressure on the garbage collector. So you can use the GoproTo library to generate efficient marshalling code to and from the wire. So how do we use protobuf for service-to-service communications? Because this is just a serialization format. So we use gRPC, of course. So who's heard of gRPC? Yeah. That's basically all of you. Who's using gRPC? Yeah, okay. Same suspects again. Cool. Yeah, gRPC is, again, developed by Google. It's the RPC protocol. It's built on HTTP2, meant to be serialization agnostic, but you normally use it with protobuf. Although it does have official support for flat buffers nowadays as well, which is another serialization format developed by Google. And like protobuf, it leverages code generation, and it comes with powerful streaming capabilities, such as server-side streaming, client-side streaming, and bidirectional streaming, which is something we'll look at eventually. This is an open source version of the Stubby framework used by Google internally for basically all of their service-to-service communications, and many Google APIs such as the Spanner and other official open APIs expose gRPC endpoints as well as HTTP REST endpoints. So what can we do with gRPC? This graph is taken from the gRPC website, so I'm just selling the spiel. It allows you to implement things in different languages. So for example, if you want to have a front-end client, okay, not front-end client actually, it's a bad example, but let's say you have a Ruby client that wants to talk to a C++ server. You just define the proto interface, you generate the gRPC server, generate the gRPC client, and you can have your Ruby enthusiasts talking to the C++ server without even having to worry about compiling anything. And there's an example of an Android Java client there as well. You can use it for mobile development, of course. In fact, I think Pokemon Go uses gRPC and protobuf for their communications to the servers. So what does it look like? So we've taken the profile that we had before, we've added another message, and we've added a service declaration here. So service declarations in the profiles map to gRPC service methods. So we've created a service method called getCatToy there, which takes a getCatToy request and returns a catToy. And as you can see, we have to add the getCatToy request message there. So presumably you would then give a catToy ID, and it would return some information, some metadata about that cat toy. And let's generate that and see what it looks like. The Go code generates something that looks like this, which is an interface that you then implement in your own server. And sorry, this is the client interface, this is the server interface. You have to implement this in your server, and obviously then look up in the database backend or whatever where you store your cat toys against the ID that the request was given, and return the cat toy or an error if it didn't exist. And on the client side, all you do is you create a client connection, and you get given a new cat server client which implements this interface. So you basically work with like any other struct which has a method called getCatToy on it, and then the entire network is just abstracted for you through that beautiful generated function. So this question comes up a lot, so I thought I'd answer it before you guys get the chance to ask it. G in gRPC does not stand for Google. It stands for something different every release, and currently it stands for Gloriosa. And for future reference, there's a markdown document on GitHub that you can refer to whenever this question comes up in conversation, as it does. I think last time I did this, we were on 1.7 or something like that. They have quite frequent releases. There's a Garcia in there. It's like someone's snuck in their name in the middle of all the other.
It's probably a deadhead.
What does that mean?
The Grateful Dead, Jerry Garcia.
Okay. Yeah, I didn't know that. Anyways.
I think that's what it is.
They're going to run out of G's eventually. I don't know where we're going to end up with like G1, G2, G3. So there's a nice recursive one there as well, as is tradition. Anyway, so can we use gRPC in the browser? Yes, with gRPC-Web. Has anyone heard of gRPC-Web before? I talked to you about gRPC-Web earlier today. That is cheating. So this is not obviously widely known. There's actually even an official client for this. So basically, the idea is you bring the benefits afforded to the backend for several years now to the browser. So binary serialization, typed interfaces, one source of truth for all of your communication needs. So there exists an official spec and an official implementation. We'll get on to later why the official implementation is crap. And it uses protobuf, and it supports server-side streaming and normal unary requests, but no client-side streaming or bidirectional streaming right now. The choice not to implement that at the moment, I think, is because they're waiting for the web consortium to agree on implementing the fetch streams API, which will have writable and readable streams. That hasn't been finalized yet, but eventually the browser should become just another gRPC client. And today you can kind of become just another gRPC client, as we'll see eventually. So let's look at another implementation. gRPC-Web from Improbable. Improbable is a company based in London. If you went to the last meetup, I know Sue was there. It was hosted by Improbable. They developed a TypeScript gRPC web client, which supports HTTP 2, uses HTTP 1.1 if it has to, kind of transparently downgrades. It supports fetch and transparently downgrades to XHR. And it also has support for WebSockets now, which is really cool, because while the official client only supports server-side streaming and unary requests, it has full bidirectional and client-side streaming support, which we're going to look at eventually. And they also have so they have two different packages that you can use. If you're using a gRPC Go backend server, you can just import a gRPC web package and wrap your gRPC server, which is really, really simple. It's what's shown here, but you can also, if you have like a Java server, deploy a little gRPC web proxy in front of it, which just looks at your web requests as they come and basically just says, yeah, this is a gRPC request now, and then sends it on. It does very little. You can look at the source code, it's very simple. And it's used in production at Improbable. And I don't know if anyone else who does use it in production, but I had a good chat with the main developer, and he was also kind of, oh, why aren't people using it? It's amazing. So Can we run Go in the browser? Yes, with GopherJS. Who's heard of GopherJS? Yeah, okay, a couple of you, cool. Who's using GopherJS? Yeah, I didn't expect that to get me real support. So, GopherJS is a Go to JavaScript transpiler written by Richard Musial. It's updated with each Go release. It has an online playground where you can play around with things, write and test it out. And, it supports nearly the whole of the standard library, including Go routines. Obviously, you can't run a HTTP server in the front end, so it can't support that. But most of the things you can do with GopherJS. It's used by open source projects such as PerKeep, which is Brad Fitzpatrick's alternative to Google Drive, I guess. It's like a self-hosted file server. One Password X, which wrote in their forum about using GopherJS, really interesting. A company called Ninchat from Finland, which is using it for their chat application, which is just a small part of their entire website. Really cool. Some people are actually using it. It has many community bindings for projects such as React, Vue, the DOM API, and WebSockets. So what do we get if we put all of this together? gRPC-Web for Go, obviously. This is my open source project. It brings gRPC-Web to Go, combines GopherJS and gRPC-Web. Uses the improbable gRPC-Web client because the official one's crap. And as such, it has support for both the client-side streaming and bidirectional streaming, in addition to the server-side streaming and unary methods. It leverages protobuf, of course. So you define a proto file and you use my custom product plugin to generate GopherJS code, essentially. What it is just Go code that doesn't import the standard gRPC library, because as soon as you import that, first of all, it doesn't work, and second of all, your file becomes like 10 megabytes big. So you can't do that. So it's written by wrapping the gRPC-Web TypeScript library and then wrapping the Google protobuf JavaScript library and then putting that together into something that's useful in the front end. And the product plugin is designed so that it looks very similar to a normal Go gRPC plugin. So if you've written a Go gRPC client already, it'll look basically exactly the same. We'll see that very soon. So what can we do with it? A couple of use cases. Obviously, browser apps. You can write Electron apps with GopherJS and do all the communication over gRPC-Web. Obviously, the benefit then is you have that single source of truth for defining the communications. There's no, oh, okay, I have to update my front-end handler because I changed the JSON type in the backend. All that just change the profile, regenerate both the server and the client. Essentially, anywhere the front end needs to talk to a backend, I say, because you can connect to several different gRPC backends as well from one front end, of course. So what does the generated code look like? If you cast your mind back to about 5 minutes ago when I was talking about the generated interface from the Go package, this is what the generated client-side interface looks like with the gRPC-Web generator. So you get this cat server client interface. It's indeed very similar to the one that is generated by the official package. You give it a host name and some dial options, and it goes to a client, essentially. And we're going to see this in action soon. Okay. So all of this is really great, right? But let's do the demo, right? So if anyone has their laptop with them, they can clone and play along with my demo here. Yeah. So this is interesting. I'm going to try and press this button, which should hopefully duplicate my screen onto that screen. I tested this before and it totally works. Okay, so now going back again, that's the danger zone. We're not going to go there. So what do we have here? Is that visible? Yeah. So you sure? Because let me just allow you to change your mind. Is that better?
Yeah.
Right. We'll go with the light theme. Very good. Okay. So what I've got here is a clean checkout of wow, I completely tabbed away from the link. There's the link, github.com/Johan Brandhorst /gRPC-Web boilerplate. You ready, Sue?
Almost.
That's good. So I have a clean checkout of it here. Did you get it? I'll take a drink.
I only know how to copy and paste things.
Should
So do I like copy and paste each one of these files into their own?
No, you can just call it.
Why do you have such a long name?
Yeah, why do I have such a long name? Some person from the US took J Brandhorst, so I can't be J Brandhorst on GitHub.
Darn them.
Yeah, see, you think that's a pretty rare name. It is a pretty rare name. I only know like another person.
You should limit it to Joe Brand.
That was always a funny joke. You know, at Cisco,
It's for yourself cake hole. Oh, it's Cisco.
at Cisco, my username, it was, they take like
100 people.
They take like a number of letters from your first name and a number of letters from your second name, and of course I became Joe Brand. There was no coincidence there.
One of my longtime friends when I worked at Cisco was named Mike Smith,
Mhm.
and at the time there were like 6 people with that name working for the company, and the people from India had it even worse.
Oh yeah. Okay. Anyway, here we are. Clean checkout. So because I've plugged this into a different folder, I'm going to have to do a separate place. I've got a handy find script here which replaces all instances of the package import with this proper package import. Now this exists in the README as well, so you can copy paste this at your leisure later. Having done that, I should have overwritten some files. Yes, it has. So next up, first thing we're going to do is turn off softly generation. I have softly generation on here normally, but it takes about 10 seconds to run softly generation, so that's just going to slow down our demo. First things first, then let's generate a self-signed certificate and generate the client, and then let's see if this works. Boom. I need to copy this because I'm going to run this in. Oops, I'm sorry. In my Chrome browser. Yeah. Ooh. You can type in "this is unsafe" on that screen, and it ignores the warning. Pro tip.
What?
You learned it? Yeah, genuinely. Yeah. Did you see that? I just typed in "this is unsafe." Yeah. On like old versions of Chrome, it was a bad idea, but I think they updated it because it became too well known. So yeah.
No spaces.
No, this is unsafe. Yeah, all lowercase. You're welcome.
There's one takeaway from this talk. Is that
Yeah. Oh, well, okay. I'll allow it. So, indeed, this does nothing. This is not very interesting. You can see that, is that text legible? That should be totally legible, right? So I've just called document body set in HTML, made a header there saying GopherJS gRPC-Web is great, which indeed it is. But this is not all that interesting. So what we're going to do now is we're going to open the web.prolo file, and we're going to define an RPC method. We'll call it getUser, and it'll take a getUser request and return a user. Well, obviously we have to define those messages. And normally, what do you take here? We take an ID, of course. And for the user, I will require some audience participation. I'm going to give it an ID, but what else do we attach to a user type? Go, name. Very good. Next. No. That sounds complicated. You can do it like a timestamp kind of thing, but that's going to be way out of scope. Okay. No, actually, I did this talk at Boston and in Budapest, and both of those times email was suggested to me. So we'll do with email. That's a good one as well. And because those are all strings, and that's not very interesting, we're going to do a uint 64 age as well. Why not? I mean, sometimes people will be older than 4 billion years old, right? 4.2 billion. You can't rely on 32-bit accuracy. So, having defined that, we just run make generate again. This runs the product with the GopherJS Apps plugin, which is the thing I've written, and the normal Go out plugin, of course, to generate the server, and it's written loads of stuff, and then we have to go into the back end and obviously define this functionality. So if I just save this file, this is not going to pass anymore because it doesn't implement the interface. Indeed, backend does not implement server.backend server missing user get method use get user method. So we'll just wow, what happened there? We're going to try and select this and then, like a pro, paste it there. Thanks, no. On the backend type, of course. Indeed, we don't even need it. And we take the context and we take a request, and this is going to have to be namespaced to the server. Ooh, server. And then we will say if rec.getID is not equal to our magic number 1234, which is the only user we have in the store, because we don't really have a store, we're going to return an error. And you'll learn a best practice here, which is that you should be using the status package when you return errors. Ooh. And give it a gRPC code, which contains well-defined codes for errors. In this case, of course, the user was not found, and we can say something like invalid user ID. And that will tell the consumer of your API that an error of type not found happened, and then obviously this is what they use to branch their client-side error handling on, not the string, of course. However, if the ID is 1234, then we will return the user, which has ID 1234. Name, I'll give it my own name. Email, something. Oops. What else did we have in here? Age, yes, and untyped literals. Thank you. And of course, not an error, so nil. And that satisfies everything. This is happy again. Of course, this is a vet error because we haven't given a comment to our exported function, but who cares? Now, in the front end, this is where it gets interesting, of course. Let's assign this variable something. And then what we'll do is, oh yeah, actually, we need to open the index.html first because we want to be able to type something here. So we'll add a div, give it ID target, and put nothing in there, and then we'll add a button, give it ID button. And that will do for our HTML for now. And then, of course, in our JavaScript, we want to attach to those things. So then we will use document.getElementById, beautifully typed. Get the element with the ID button, and this is a interface, so we can type assert this to a dom.html button element. Beautiful. And then obviously that exposes certain things that you can do on the button. And the div is a document.getElementById target, which is a dom.html div.
Ooh, visible target.
Okay. Oh yes, that's a good shout. That wouldn't have worked. That could have been embarrassing. You saved me. Thank you, sir. So that gives you the div element, which is great. We can remove this stuff. We won't need that anymore because we've created some a button and a target. Now what we want to do to make things interesting here is to attach an event listener to the click event on the button. And this takes a function which gives you an event, but we don't need that. What's the type of this actually? No, it's DOM not event, of course. Well, we don't need it anyway, because this is a closure and we can do whatever we want. So now we can call getUser, we can give it context. We can give it context to the timeout, that will all just work. It will cancel backend calls as expected. But let's just keep it simple and get give it a get user request with an ID of 1, 2, 3, 4 because I want to show you the success case first. And this is very familiar, of course. Now we can't return anything from this function, but what we can do is do targeted.set in our HTML to actually it's like a set text content. That's the one we want. And then we can just do error and return, of course. But if we successfully get the user, then we want to write some information about this user to the div that we created. So let's take ID, and then this is just string concatenation. Get age. Now age is a unsigned integer, so that can't just be willy-nilly appended to a string like that. So we're gonna have to do a strict format uint on that. Fortunately, that can't error, so we can still do that inline. And what did I do wrong here? Oh yes, it takes a Google in here, which we don't care about, so we'll just set that to something like that. Okay, now we've defined what we want the button to do when we click it. So let's regenerate that. Worked, which is good. Let's reload the page. Let's start the server. Let's reload the page. Okay. There it is. Okay, we've got a button. But let's make things a little bit more interesting by looking at the network transmissions that happens. Oh, what happened? There's a console error in here, I'm sure. Yes, okay, I did something wrong. Ah, yes, classic. You have to wrap it in a Go routine. Because CLI.getUser is a blocking function. This happens every time I do this thing. Because this is a blocking function, you can stick it straight into the function body of an event listener because JavaScript doesn't support having blocking code. So wrapping it in a Go routine just means that it does what you expect it to do, but it doesn't break JavaScript. We'll regenerate that. So again, and ta-da! Thank you very much. Let's take a look at because I think this is really interesting. We can look at the this is the request I was sent, and this is actually just base 64 encoded binary data, of course. And this here is the data that was sent back. So you can see some of this is just binary garbage. Some of it is obviously legible, and some of this content type, header type, trailer type thing actually. This gRPC state says a trailer, which is something else that gRPC has on JSON. So that worked, which is great, but it's not all that interesting. How much time do I have? Yeah, okay.
When do people want to leave?
You can start walking out when you're not interested anymore. So I think this unary case is interesting, but I thought I'd show you how to do some server-side streaming as well. So let's go back to Proto and show you just how easy it is to implement a server-side streaming thing. Boom, that's it. We don't even have to change anything. Or we just said this is a stream of users now instead. And what that does when you generate it, we're going to get some build errors. Not to worry. It means that the function that the backend has to support has a little bit of a different signature. It gets a single request and then it pumps users onto this server. So let's implement that. Yes, still worked. And that's the initial request, of course. This was usually just called SRV. And this is an interface. So you'll be really grateful that it is an interface when you want to test these kind of things, because it makes it super simple to test. You just generate like a fake interface, or you write a fake interface yourself, and give it to the function, and you can assert that it calls things that you expect it to call. So we can do the same handling again. If the ID isn't right, then let's just return with an error. Sorry, I forgot to show you the error case. I'll do that later. But if we do provide the correct ID, then just let's do this. Let's send 10 users. And instead of returning it directly, what you have to do is use the server that we have, server.send. And this is typed as well, as you expect from Go. And it can return an error. And if we get an error, we just return oops. Let's just return error with the error. Otherwise, return nil. So we'll send the same user 10 times.
You don't have to wrap that in a Go routine then?
This is in the backend. So the backend is much cleverer.
That's right.
Yeah, it's just the front end that you have to mess about with things. So we can use the same button again. We can even use the same div again. But it'll be easier if we make the content a string here. Actually, that's silly. We will when we call get user, we will get a server which we read from instead of. So we'll have to do something like an infinite for loop. We will do serve.recv, which returns a well-typed user. And we can do the same kind of error handling again. It's not particularly sophisticated here, but who cares? And if we get a user successfully, then we will just append to a string, and we can write the string out at the end. So let's take this beautiful logic that we already have, and let's do like content plus equals that, and let's stick a new line at the end here. So. And then at the very end, we just set this to content. Now this is interesting. Will this work immediately? Let's try. Okay. That was unexpected.
I'm so harsh.
Oh, because it'll keep going until it gets to the end.
Ah, you're right. If error is equal to IOEF, we want to return without overwriting everything. Okay, of course. I did prepare this. Otherwise, we'll print the error. So that should. No, we don't want to return. We want to break out, because otherwise this code is never reached. So we break out of the for loop, and then everything should totally just work. Hello? Okay, well, new lines don't render well in there. But there you go. So now this is a chunked response. So even though everything obviously came at once here, if we'd added some sleep or something in between, which we could have done for the purposes of this demo, you would have seen how it's streamed from the backend, which is obviously really powerful for delivering chunked data to a user. Now I have prepared a bidirectionally streaming demo as well, which I thought we could do, and I thought I'd spare myself the pain of failing 3 times. And let me just. What interface did I use for that? Wow. Send client message. Okay. I think this was just message and message. And that took a string. It must be string. Okay, let's try and. Okay, so to create a bidirectional streaming message, we obviously just put stream here. Again, if you remove stream from this side, then it becomes a client-side streaming message naturally. So that has generated the product file, but we still haven't implemented the backend. So if we try and run the backend, it's all going to go terribly poorly. So let's implement that one. Let's type here. Okay. Backend ping server. Error. So let's read from the client, read a message. And then send the same message back again. Now, reading and sending can operate independently in independent Go routines, so you can have something reading in one Go routine and sending completely asynchronously, and it all just works. You cannot have two Go routines receiving at the same time or sending at the same time, but receiving and sending can be done in separate Go routines without any problems. So let me just think here. So I think we need a class here for if is equal to io.uf, and just to return nil in that case. This probably shouldn't necessarily, does it detect that infinite loop? Yes, it does. Interesting. Okay. And then I just realized I haven't changed the index. I need to add another button here. Now I'm going to infer what I need from looking at this pre-prepared JavaScript here. I've got an input. Okay. So I think we need an input element here. Let's see if that works. We're going to need to rebundle this. What this generates does, in addition to generating the profile, generating the GopherJS, is bundling the GopherJS and the HTML file into a static file that is then hosted by the Go server itself. So I probably should have mentioned that to start with, but when I run make serve, it starts the gRPC server, but it also hosts the JavaScript and the index.html file on the root. So that's why I can go to this page and it shows the JavaScript. So let's see if this works. That happened once. That didn't work immediately. Okay, so last time I did this, I was missing a loop somewhere. That has a loop. This doesn't have a loop. Okay, so it's no more than one thing that it didn't send it more than once. Actually, maybe that's what I wanted to show. I forgot from that. Let's, yeah, so I closed the server and we got the gRPC error. Let's see, maybe this is actually what I intended all along. Yes, there we go. You can control the sending and it just receives on the same message the entire time. And this, of course, uses WebSockets and binary frame WebSockets at that. So let's reset that again. Because you can change this data, of course, and it sends it, and the server just replies. And there's like no separate requests here; it's all over the same WebSocket. So that was that, I think, for the bidirectional demo. Kind of worked. So let's go back to the presentation. I have more presentation here, but I realize I might already be going over my time.
People want to continue?
Yeah. So
how long?
I can probably do another 10 minutes if you guys will be generous with me. So let's see if I can stand back up again. Okay, yes, that's working. Wow, that cursor's not supposed to be in the middle. Let's move that to the side. Right, so I thought I'd mention some challenges of implementing all of this. As I mentioned, there's both an official client and the improbable client. And there are pros and cons of each approach. The official client is obviously an official client. So it's implemented by Google employees. It's based on the Google Closure compiler, which is like a JavaScript framework that's like Webpack, but it seems to be used only by Google, basically, as far as I understand. And it uses the Google Closure library base, which I actually thought was really cool. Someone who doesn't work with JavaScript a lot, I thought Google Closure, the ecosystem there, seemed to be very cool. Unfortunately, it doesn't support. When I tried to do this, it didn't support a lot of normal cases. Nowadays, it doesn't support client-side streaming or bidirectional streaming. The documentation is really poor. Like I basically have to go and look at the source code to get anything done. And because the backend proxy is a Nginx plugin, it was really hard to get it running at all. I don't think I ever managed to get it running. So basically, that was what held me back from even trying to use this in anger. And it still today seems to be an Nginx plugin, although the improbable proxy is also spec compliant, so there's basically no reason to use their proxy. So the improbable client, on the other hand, spec compliant, well maintained, well tested, well documented. It has the proxy is written in Go, which means you can dive into the code. It's really easy to understand. I mean, not only as a Go programmer, basically any programmer with any experience with imperative languages will have an easy time reading Go. And easy to build, basically, because the Nginx plugin, I mean, it was like a dynamically loadable plugin, so I had to compile it to C++, which is obviously a nightmare itself, and then load it with Nginx. So like it was really hard to get anything going there. On this, on the other hand, you just go in, change the source if you need to, recompile it, super easy. Cons, third-party clients, obviously not the first choice when it comes to choosing. You want to go for the official thing. I dare say using the Webpack compiler is also a con here, but I think some JavaScript enthusiasts might say actually Webpack is the preferred one. So that's probably up to you more like. Okay, so in the end, I obviously went for the improbable gRPC-Web client, but I aim to revisit this when and if they become compatible, because at the moment the gRPC requests produced by the official client isn't compatible with the gRPC-Web proxy for some reason. Like apparently they're both spec compliant, but they're not compatible. So I raised issues in both those repos in order to facilitate some kind of cross-testing where the official client would test against both itself and the improbable client and vice versa. Ideally, we'd all converge on one of them, and ideally would be the improbable one because it's just much better. But we'll just see how that goes. And that's it for now. So another big question for me was how to generate the serialization output. The improbable TypeScript generator depends on the output of the JS generator. So it basically just generates a TypeScript class definition, and it requires you to output that into the same directory as you have generated the JavaScript output files already. So there's like this nasty dependency on a separate generation call. But obviously that means that they didn't have to generate a lot of the logic in order to do the serialization. So the alternative is basically duplicate all your own logic or depend on the output of the generator. So depending on the output of the generator means that you can keep your own generator much simpler, and you get the benefit of all of the work that goes into that official generator automatically into your own serialization. Unfortunately, this is the choice I initially went with, and unfortunately it's like an awful user experience because you have to do things like edit the generated JavaScript files in order to include things if you're using any imports. This is taken from my old README where you had to like run sebs to replace things, and it was a mess. So I decided to actually try and duplicate the logic, which would lead to much improved user experience. But the problem then, of course, is more generator work and greater testing burden. But in the end, I think I'm actually really happy with this choice because even though I thought it would be really hard to get everything working, it was really nice to just have a wrapper around the Google Protobuf JS package which implements like an interface like this, where you so then the generator would just import this and call write in 32 or read in 32, things like this, and it produces really nice GopherJS code, and it's obviously quite lightweight as well because it just wraps the package itself, and it's completely independent. You can just use the GopherJS generated file. So another problem that I had to face with serializing my own data was supporting 64-bit integers. Now, JavaScript developers in the room will probably know that JavaScript numbers are 64-bit floating point numbers, which suffers from a lack of accuracy above 53 bits of data. So when you try and send a large number across the JavaScript, or even for JSON, it will sometimes be truncated to a number that fits, or you will have to use strings. And I thought it would be really cool to have native 64-bit integer support. And not even the protobuf.js library has support for this kind of thing. So what I did was I sat down on the weekend and I wrote my own serialization to and from the wire, basically. These beautiful bit shift operations were inspired by the GoGoProto generator, the library I mentioned before, which produces efficient code. I include these two snippets because they're probably the most interesting parts of the generator. The zigzag 64 format, right, is specific for the protobuf type, which it's a variable size integer, which is supposed to be efficient around 0. So when you have like an assigned 64-bit integer and you want to serialize -1, it becomes huge, obviously. So if you want to have a lot of values that's centered around 0, you use the zigzag encoding, which encodes the unsigned number 1 as 1 and the signed -1 as an unsigned number 2. So it kind of zigzags across the number line as the numbers get larger. And this is apparently how you convert an int64 to a uint64 for the wire. It's beautiful, isn't it? I have no idea how it works. But fortunately, another part of this was testing package compliance, of course. I wanted to make sure that the serializer, having written it myself, would work, essentially. And especially at the extremes, like the maximum signed integers and unsigned integers, and also to validate the gRPC-Web client functionality. And what I did was basically create a Go server, just have the same request as a response, and I would then try and send a request from the front end to the Go server. The Go server would unmarshal it, do nothing with it, send it back again, so marshal it to the wire. So, and then I would, in the front end server, this is the wrong part of it. Anyway, in the front end server, I would then compare the message I received from the back end against the message I sent. So obviously then, if they both are equal, that means that it's all been serialized to the wire, from the wire, to the wire, from the wire successfully. So basically using the Go gRPC server as an oracle to validate my serialization. Okay, having said all of that, future work for my library and for GopherJS in general includes WebAssembly. Now, this is a really new web standard for, I dare say, replacing JavaScript entirely now. But I'm really excited about WebAssembly, and as I mentioned to some of you before, I'm currently working on getting this kind of thing working with WebAssembly natively without having to wrap a TypeScript client. So you could just write the Go gRPC client. It would probably still be a separate package. Maybe eventually it could be part of the gRPC Go client functionality. But essentially keeping it all within Go as much as possible, relying on the fetch API for backend communications, and not to generate to JavaScript at all. So let's just have a brief summary of everything we've discussed. So we've learned to use gRPC-Web for Go. We've learned to define our product packages, generate the code, write the backend, write the front end, and see that it all works beautifully together. We've learned that essentially what this allows you to do is take the graphic that we had from the start with and then add your browser client on top of it. So you have this beautiful graph where everything uses protobuf on the wire. You use the gRPC-generated clients for communication, and all of your business logic is just written in the package, the library of your choice, including in the browser. Okay, so I'd like to thank Michelle for inviting me here, and obviously Speechmatics for having the meetup. Thank you, and for the pizza. Improbable, and specifically Michal Witkowski, who has been really good at bringing open source libraries for the gRPC ecosystem and open sourcing it on GitHub. He's one of their principal engineers or something like that at Improbable. Richard Musial for developing GopherJS and the WASM target for Go, which is going to be available in Go 1.11. Dmitry Shyalov, who's the maintainer of GopherJS at the moment, and he's doing a lot of good work for GopherJS in general. The GopherJS community, which is there's a great Slack channel, and the issue board is there's a lot of helpful people there who can help you if you're just getting started. Paul Jolly, who is one of the frequent attenders at the London meetup, who encouraged me to talk about my own projects, and of course you for attending this meetup. So thank you, everyone, and I'll take any questions.
Thank you. Just a quick one for the. You said they were using WebSockets to do communication. But
Yes.
where is that done? Because if you do a normal streaming in gRPC, that's not done through WebSockets, right?
Yeah, no, that's right. Normally gRPC relies on HTTP2 data frames for sending back and forth, but because the browser doesn't support HTTP2 trailers, essentially, you can't do that. That's basically the reason. Eventually, that will be supported with the Fetch API, I think, which would basically mean it's wire compatible with normal gRPC traffic, like you say, just pure HTTP2. We use WebSockets. So originally, I don't know if this is what inspired Improbable in the first place, but I actually wrote a Go-specific implementation of this WebSocket wrapper for my library. So it supported bidirectional streaming and client-side streaming before it existed in the gRPC-Web implementation. Then they wrote an implementation which was much better than mine. So I threw mine away, and now it's relies on their implementation, which is beautiful, by the way. There's like a really clever piece of code there which implements the WebSocket connection as a body, and then implements the response writer as a WebSocket writer as well. It's mind-blowing. Basically, what they're doing is just they have this wrapper for the body, they have a wrapper for the response writer, and they just give that to the Go HTTP2 server. It's amazing. It's like there's no custom logic for HTTP2 or anything like that. It's just implement these two interfaces, hand it over to the Go gRPC. Like, I'm baffled. It's so cool. I think it's a prime example of the cool stuff that Go interfaces in the standard library allow you to do. It's amazing. Anything else?
How did you learn to type so fast and accurately with people watching you?
Do you think, well, so I've
It
delivered
never
this
works for me.
I've delivered this talk twice before, and so I'm a little bit confident. Yeah, I'm kind of confident about what I'm supposed to be writing, but I don't know. Like you saw the autocomplete, like just tab. I mean, I could have embarrassed myself if Michelle hadn't noticed that I had mistyped my stringly typed ID. No, that could have been badly, but yeah. No. Oh, thank you. I guess that was a compliment.
Yes. So what's Google's take on this kind of thing? Are they trying to do similar things? Are they using this kind of thing in production? Or?
I have no idea. I mean, so the way that things work with Google, I think, is they develop something and they like have it internally for 5 years, and then they're like, maybe we should open source it. So it wouldn't surprise me at all if gRPC-Web in some format has existed within Google for years already. And then they decided, well, okay, we should probably open source. Because this is basically what happened with Kubernetes, with gRPC itself, which was their, and you know, generally container orchestration and all of the surrounding, like AI, it's happening to machine learning right now, I guess, in some sense, with TensorFlow. They just seem to be developing a lot of things internally, and I guess they must be discarding a lot of things as well, but eventually some of that makes it to the open source world. So I don't know, but I think they probably do use some of this, at least internally.
Have you looked at any
the kind of start with the proto definition and then generate not just a Go code but also like swaggery.
Yeah.
Have you looked at that?
Yeah.
Is
So,
that successful? Is it a total waste of time, or is it something that's?
I think at work actually we started with so there's a project called the gRPC Gateway, which allows you to do basically this kind of thing, but instead of having a gRPC-Web client, you have just a normal JavaScript client that speaks JSON. So it allows you to expose the gRPC backend as a RESTful client. And you kind of annotate your profile a little bit, and it can generate a Swagger file for you. It generates a Go proxy for you that defines the handlers and just speaks to the backend server and translates it back and forth from JSON. And we use that at work in production, so to speak. I know a lot of companies who are hesitant to do this kind of thing have jumped on the gRPC Gateway bandwagon because it's so easy to integrate your gRPC services with things that just want to talk REST and JSON. So you can define your protofiles. They generate them you can generate them Swagger files. From those Swagger files, you can generate other things, of course, or you can just generate things directly from the protofiles. Like I think there are generators out there for JavaScript and TypeScript interfaces straight from the protofiles. But if you wanted to rely on things like Swagger OpenAPI, which is more common in the JavaScript world, probably you can generate straight from that Swagger file as well. And it is a little bit quirky, but I mean it's an open source project. You can contribute problems.
Problems I can contribute, yeah.
You can contribute problems if you want to, but ideally you would contribute solutions. I've made several contributions to the gRPC Gateway project itself. I have a thing I want to implement for the Swagger schema soon because we're going to be, the API I'm working on at work is going to be exposing a gRPC Gateway generated API, basically a REST API. So I think that project, it's more mature than this. Yeah, I think it's worth trying at least. Anyone else?
I've got another question.
Yeah.
So I saw you posting something about the generated Go code and it being a bit chunky. What's your plans with that?
How do you mean?
So to get rid of all of the XXX bits and the.
Right. Well, we can. Why don't we take a look to just. So the generated files are in here somewhere. These things were added in a recent release of the official Go gRPC package, and some of them are there in order for you to not be able to use these as unkeyed literals. So this XXX no unkeyed literals means that you can't create a message struct without explicitly saying which field you want to assign something to, because it breaks backwards compatibility if you add a message and it might change the behavior. So they added this thing, which an empty struct apparently prevents you from doing that. And these, I'm not entirely sure what these things are for. You can't remove these. They're a part of the struct. You kind of just have to live with them. But what I did say was that you can use the Go protobuf generator to generate better marshalling code, essentially. But you can also use it to change things like the generated name of the field. You can change the JSON tag if you wanted to. You can, if you use an official Google protobuf timestamp type, you can convert that into a time.time, like a Go nicer, because otherwise what you get. So sorry, I should start from the beginning. Google protobuf has these well-known types such as a duration, a timestamp, and other things. And basically, when you include them in your structs, they guarantee that you can use those representations across the different languages, and they will all be well supported. But it's a little bit nasty to work with a custom struct. It will be a struct like this that allows you to set like a number of seconds since the epoch or something like that, and then a number of nanoseconds relative to that second, I think is how the duration works, or timestamp. So what the Go protobuf generator allows you to do is just use a time.time, and it's taking care of all of that translation for you. So I use Google Protobuf at work. Now I'm not used it here because it just complicates the example a little bit. This is meant to be a boilerplate and as simple as possible. It hasn't dived into that more advanced step. But I've written quite a lot about Google Protobuf on my blog, and you should know before you dive into Google Protobuf that it has certain incompatibilities with the normal Protobuf package. And if you read my blog, you'll see which. And I'm fairly confident you can work around all of those, but it's still some incompatibilities. Having said that, the Go Protobuf project is currently working on a major refactor, which should allow Google Protobuf to exist completely compatibly alongside the normal Go project. They are aware that people want this extra customization for their structs, and they're keen to allow people to use both their official generator and other generators. So watch this space. I still think Google Protobuf is well worth using today, though. But you should check out my post because it just details the problems you might run into before you run into them.
So is there any reason why somebody wouldn't start with a proto file to generate a Swagger file to generate a client library? Or is there any reason why somebody might still go for writing a Swagger themselves?
Well, I've never manually written a Swagger file, but I guess it's just a different kind of.
It's a bit more well known, I
description.
guess, by a lot of people, and they might say, I don't know what gRPC is, but I know what
Yeah,
Swagger
I
is,
think,
I'm
but I don't
comfortable
think
with that.
people use Swagger for backend communications. Is that
Yeah,
maybe I'm wrong? I think it's mostly like a backend, front-end, back-end, that layer, which is good, of course, because it's still better than just manually writing handlers on both sides. But if you can use Protobuf for both your backend services and your front-end services, and Protobuf is a great interface description language to have. Yes.
So I had a discussion with a tester today, and it was to do with the difference between REST and gRPC interfaces. And he was saying that he likes REST because it's really easy to like manually test with curl because you can just like,
Yes.
get post and then put a URL
Yeah.
in.
This is a fair point.
Whereas things like gRPC, you actually have to write and implement
Well, you
code
can
that
use
uses a
you can
library.
use gRPC code.
Yeah,
But you have to write
You still
code.
have to write
That's
code.
what I'm saying. You have to write code and import the library.
No.
It's
There's a tool called gRP curl,
Oh, okay.
which allows you to basically you can say gRPC curl this profile and then give it like a JSON body, and it will translate that and send it as a gRPC request. So you can do that. But actually, what we use at work is we've just deployed one of these gRPC gateway with every single server that we have, and a Swagger interface produced by the generated Swagger file. So if you want to go in and debug a server, you just go into the debug interface. It has a beautiful Swagger. Let me show you. So I wrote this gRPC example thing for the Gopher Protobuf project, and basically you get a website that looks like this. Great. Anyway, and then you can just fire your requests in JSON. You get replies in JSON. It does the translation itself. It's fairly trivial to deploy this together with your gRPC server. Obviously, this still doesn't reproduce entirely the communications that you're doing between two different services. But we've never really found the problem with using this for debugging. Like sometimes you'll be like 3 services deep in your request microservices.
Sure.
And you'll be like, oh, okay, so this service sent this to that server. Okay, I'll just go there, try and reproduce the request, see what the error is, check the logs. And that has just always worked well for us.
Okay.
Now people say you can use gRPC curl. You can probably use curl itself as well if you want to, but I think this is much easier.
So just knowing about that's useful. gRPC, curl, gRP.
There's actually like
curl.
3 different ones, all called
Right.
gRP curl, because it's like a pretty easy to reach for a pun when you want to implement a curl for gRPC.
so.
I'll mention that.
I had one play with it because I was looking at the Swagger generated stuff,
Mhm.
and the little bit of code that looks at the content type to switch between the two things, it didn't work if you don't use proper certificates. The
Or
MIME type.
certificates.
At least, it didn't have to be a real certificate, but it had self-signed. If you do plain text one, it just didn't.
Okay.
Probably finger trouble on my part, but it just didn't
Yeah.
There might have been content types derived from gRPC tails specifically.
Okay, interesting. Yeah. Anyway, I mean, it is just an HTTP request underneath, so you might be able to marshal it manually and literally just run it with code if that's what you want to do as well. But, or you can write a manual client, like you were saying. So you just import the type and write the client, and you can do like a command line interface essentially against your own service if you want to.
Yeah.
But yeah, this has worked really well for us.
Cool. So you just have that switched on during debugging?
Yeah.
And then you switch it off?
I mean, we have it in our integration environment. You can it's just on a separate port, essentially. It hosts both the gRPC gateway and this, and then you just, you talk to the gateway translates it, sends it to the server. So we have a whole kind of deployment of our system where you can interact with it via the Swagger interface. Anything else? Cool. Thank you, guys. This was great. You guys are much better at questions than all of the other talks I've been to. There's never been much interest, to be honest. Although, actually, you didn't ask about the size of the generated files, which was one of the common questions from the other places I've been to.
How big were the generated files?
There you go. Right on cue. So you notice I turned off softly generation of the softly compression of the files at the start of the demo, but actually maybe we can take a look. Nah, never mind. But I think the GopherJS files will normally be in the range of 1 to 5 megabytes uncompressed. You can compress it down to as low as 30K, apparently. The people I was talking to at NinChat, which I mentioned before as one of the professional users of GopherJS, apparently their whole chat application is less than 30K GopherJS, which is like on par with JavaScript applications, I dare say.
Yeah.
So can you do anything interesting with like distributed tracing now that you can kind of do that on the front end, I guess, as well?
How do you?
Like, I don't know, like Zipkin and Jaeger and all these Go distributed tracing tools.
Yeah, but it has little to. Oh, you mean can you trace the front end requests?
Yeah.
Will they actually run in GopherJS? Can you send out? That will need to send out HTTP requests.
GopherJS doesn't have any wrappers for that kind of thing anymore, yet, I should say, but your gRPC server should log the incoming requests as they happen. So you'll get most of it in your tracing. Yeah.
I just wondered if that idea makes sense.
Yeah, absolutely. That's really interesting. Yeah, we've actually just started deploying Open Census at work, which is uses Jaeger, or it supports Jaeger, but it also has support for Zipkin, I think.
Yeah, it does.
You tried this Open Census?
No, but I was looking funnily enough at it today as well, because we use sort of
Really?
Zipkin as a
Yeah.
backend.
Open Census is a really cool technology. There was actually the presenter after me at Boston was JBD talking about Open Census. That's where I learned about it.
Yeah, she's one of the instigators of it.
Yeah.
Well, we need to pick a distributed tracing technology. I hand-rolled it twice now, and it's interesting, but not that interesting.
Okay.
Thanks very much, Johan. And, thanks everybody for showing up. We hope to see you next time. So if anybody's interested in giving a talk, please let Adam know or me on the on the meetup.
Well, I can.
Feel free to reach out to me if you have any more questions about that, of course.
Yeah. Well, at the moment we're.